This is 4.5 from the textbook, U substitution. U substitution is essentially the reverse chain rule for integrals. So in this integral, for example, you have the function within a function g of x. So f of x of g of x, the composite function. So what U substitution is, you would take g of x, and that would equal u. So after doing that, we can simplify the integral into the integral of f of u times du. In this case, it makes the integral of antiderivatives, which is a lot easier to solve for the function. Two types of integrals we work with in this case. There's indefinite integrals and definite integrals. First, indefinite integrals would start, you don't have your a or b, it's just the integral of that function. So you would start off by figuring out what is our u. In this case, we want our u to be within this term because we take the exponent of that term. So u equals 6 minus x cubed. Taking the derivative of this, we do du equals negative 3x squared derivative of x. So we would solve for dx, which equals derivative of u divided by negative 3x squared. Going back to our original equation, to the derivative, or the integral, not derivative, integral, x squared times u to the fifth times dx. Well, in this case, dx is du divided by negative 3x squared. Our x squares cancels out, so we would have negative 1/3, pulling that out of the integral, is u to the fifth times du. So, taking the integral of u to the fifth, you have negative 1/3 u to the sixth divided by 6 plus c. So, our integral is negative, back to our u, which is 6 minus x cubed to the sixth power divided by 6 plus c. And that is our final answer, which is the integral of x squared. Oh, that would be 18, not 6. That's our final integral of this function. So the definite integral is different. We would work this differently. So in this case, we would still find our u, which would be u equals 1 minus x squared, because that's under our radical, and then du would equal negative 2x dx, making dx du divided by negative 2x. But because we have the definite integral, we have a and b, we would need to change our a and b to u. So we do the u of 0, which is 1 minus 0 squared, which is 1. Then our b value, so it would be u to the 1, which is 1 minus 1 squared, which is 0. So, pulling that back, we need to change a to b to what we solved for here. So this time, 1 would be on bottom, 0 would be on top. Then we would go back to our original, which would be x times the radical u squared, square root of u times d of x, which, as we pulled here, u divided by negative 2x. X is canceled. We have negative 1/2 times the integral 1 to 0, u times d du. Then we would need to solve for that, the integral of square root of u, so it would be -1/2 times u to the 3 over 2 divided by 3 over 2 multiplying b to 1 to 0. So simplifying this, we can solve. It would be -1 over 3 u to the 3 over 2 to 1 to 0. Now, we know that 1 to 0 is the same thing as 0 to 1 multiplying by -1. So it would be 1 over 3 u 3 over 2, 1, 0 to 1 this time. So, bridge that. Then, using the fundamental theorem of calculus, we would solve that and we would find equation is integral of that simplifies to 1/3. The definite integral of this function is 1/3.